morning. Right, I think we can start. Right, can one confirm if you can see my screen?
Yes, sir, we can see it.
You can see my screen.
Yes, sir.
Okay, let me configure my mic. I think there's something wrong with my mic here. Right, so today we are going to look at static routing. We've been looking at creating ones. Okay, last week we were looking at how do we create ones, where wide area networks. So we want to look at how do you assign, or how do you make sure that a router is aware of remote networks? That's what we want to look at. Right, so in networks, there are what you call routing protocols and the routed protocols. So a routing protocol is used to dynamically assign networks, okay, to routers. It's mostly used by routers to dynamically find all networks in the internet network and to make sure that the routers are sharing the same routing table, right? So a router can know about remote networks either by dynamic routing or by static routing. So basically, a routing protocol determines the path of a packet through the internet. It determines the path of a packet in the internet. Okay, so by routing we mean we are routing a packet from one device to another device on the internet. So we have different types of routing protocols. We have RIP, which is version 1 and version 2, with EIGRP, OSPF, BGP, and so forth. So these are the main routing protocols which are used in networks. And most of routers, depending on which company, when they are sold, they also come with the activated for each of these routing protocols in their operating systems, which you can then configure on each routers. Right. So let's look at the difference between a routing protocol and a routed protocol. Okay. So a routed protocol can be used to send packets through the established path by routing protocol. So a routing protocol creates a path. Then the routed protocol is responsible for delivery of packets on a path which has already been created by a routing protocol. So a routed protocol is also responsible to assign IP addresses to interface, which refers gateways. And example of routed protocols, IPv4 and IPv6. These are routed protocols. So the routing protocols, and the routed protocols are here. IPv4 and IPv6. That's the routed protocol that we have. Right. So the term routing is used for taking a packet from one device and sending it through the internet to another device. Of course, all the devices will be on the internet or on the network. So basically, routing is on different networks. Okay, because if we're in the same network, we need a switch, and basically a router is not needed in such circumstance. Right. So routers therefore are then needed to establish these paths. Okay, a router does not care about host addresses. It only cares about network addresses. and it is also responsible for creating the best path that each packet can take. So a router can only learn about its remote networks either by dynamic routing, which means it gets information about the remote networks from its neighbors, or it learn about remote networks from an administrator. A network administrator manually configure remote networks to that router. That's how it become aware of remote networks. So when a router learn about remote network, it logs those remote networks in its routing table, so that it is aware of remote networks and how to access those remote networks. All right. Right. So let's look at the routing basis. So we're saying the router then builds the routing table that describes how to find the remote networks. If a network is directly connected, then the router is already aware of that router, of that network. Okay. You remember last time you see that if you see a C, if you write a command show IP route to a router and you see a C, it means that network is directly connected. If a network is not directly connected to the router must use one of two ways to learn how to get to the remote network, either statically, that is means somebody should manually configure the router, or it would learn from its neighbors, which we call dynamic routing. So if you are using a routing protocol, for routers to exchange data, they have to use the same routing protocol. So a router which is configured RIP cannot exchange information with the router which is using OSPF, for example. So they have to use the same routing protocol for them to exchange routing tables. So on dynamic routing, a protocol on one router communicates with the same protocol on another neighboring router. Okay, the routers then update each other about all networks they know about and place this information in the routing table. If a change occurs in the network, the dynamic routing protocol automatically inform all routers, all its neighbors about the changes in the network. That is if a certain router is directly connected to a certain network and that network is down, it has to share that information with all other neighbors that my directly connected network is down, so that all other routers, when they receive packets destined for that network, they will drop those packets because the network is unreachable. So the ICMP protocol is then responsible to deliver to the source that the network that you want to reach is unreachable. Right? When the network is up again, the router which is closest to that network will also share the information with all the routers that there's another new network. Right. So in static routing, the administrator has to type or to configure the router or routers about remote networks. Okay. But in very large networks, you have to use both dynamic and the static routing. What are the benefits of static routing? Number one, there's no much overhead on the router because it is not processing much processes, okay? Because everything is manually configured. So you can actually buy a cheaper router that you use for static routing. There's no bandwidth usage because there's no much information which is being exchanged on the routers. So you can save money on one links. That's number two. It also has a security, but the administrator can choose which networks you want to connect to. Okay, so you can allow your router to connect to other networks and then disallow it to connect to other networks. So that's another issue of security again. But the disadvantage of static routing is that the network administrator must know the internetworks, because if you want to configure it, you have to know all the remote networks, right? If there's a change in the internet network, the administrator should also configure all those changes. But this is actually, it's not feasible in very large networks because it becomes a full-time job, okay? Every change in the network, you have to configure it. Every change, you have to configure. So it becomes very tiresome to do that task. Right, so let's look at some of the commands or instructions that you can write on a router. If you say show IP route, this command tell you the networks, or it actually displays the routing table. The router displays the remote network that it knows and how it knows them. So if C is then connected, is F. If it's labeled S, it means it is known from a static configuration. If it's S star, it means a default route. If it's O, it means it is landed through the OSPF protocol. If it's D, it is landed through EIGRP. If it's R, it means it's landed from RIP. Okay. So if you are configuring a static route, you say IP route, then you put the destination network, or the remote network, which you want your router to know, and its corresponding subnet mask, as well as the next hop. The next hop is the exit interface. How do you access that remote network? All right. So that's how you configure static route. If you want to remove the static route, you just say no IP route and do the same. Okay, which means you are removing that network in the routing table. Right. So the same thing that I've explained on the slide before. IP route, the destination network, its corresponding subnet mask, and the exit interface, or the next hop, how to access that network. So let's see this network, which is labeled like this. We have two routers here and their corresponding LANs. The other one is 2.0, the other one is 3.0/30. The other one is 1.0/24. So if you, to router 1, this network is remote. To router 0, this network is remote. So if you want to make sure that this router is aware of this network, you would say IP route 192.168.1.0 space 255.255.255.0. Then the exit interface is this one, 192.168.3.2. All right. So that's how you configure a static route on this router. In other words, you are telling this router that there is this remote network. Okay. Last time we would just configure RIP here, and then these two exchange automatically their routing tables. So today we want to learn how to do it manual. So I'm going to do this for you. Then you guys, you are going to do this as a network alone. Okay. But I will just tell you how many remote networks do we have per each router, and then you go and configure that network. So let me demonstrate how do you do this one. Right, so let me put my routers here. Let me use 19 photon routers. Right, how many switches do I have? There's 2 switches. All right, there's 2960 switches. All right, so this one, the serial ports for these routers are not activated. So I need to pick the serial ports. And activate them. Again here, switch it off, pick the serial ports. Sorry, my router is still on. I need to switch it off. All right. Right, so I need to connect my ports with this DCE cable. 00/0/0. The same thing here. Right, and okay, let me put my devices here as well. Right, so for other devices, I need to straight through cables. So let me do this gig 0/0. And then I connect the rest of the devices on the switch. Yeah, sorry. Right, so the devices are now connected. What you want to do now is configure the routers. So if I label them, this is 192.168.16 2.0 is slash 24, which means 24 bits for the network, 8 bits for the host. Sorry, yes, it is also 24 bits for the network, 8 bits for the host. Right, this is 3.0 slash 30, 30 bits for the host, 30 bits for the network, 2 for the host. And the last one is this one, this is a 1.0, which is slash 24. 24 bits for the network and 8 bits for the host. Right, so let's configure this router. It's very simple. We can start by doing this. Config terminal, enter gig 0/0. The IP address is 192.168.2.1 for the gateway. Subnet mask is a /24 0. No shutdown. Right, we can also configure DSP for all other machines in that network. So we can say IP DSCP2. Okay, sorry, for 1 network 192.168.16.0. Subnet mask 205.255.255.0, and the default router is 192.168.16.1. DNS server, we can say 192.168.16, probably .100. Right. That's the LAN site. Okay, that's the LAN site. And then, right, I need to configure the other port. So I'll say int serial 0/0/0, IP address 192.168.16. There's a mistake here. I think I made a serious mistake. 16.0. Right, there's a mistake here. It's no 16 here. It's no 16. Right, should look like that. All right, so what I can do for this router is easy. I will say, all right, I need to check. If you made a mistake on configuration, you can say erase, setup, config like that. Then you say confirm, then you say reload, like that. Yes. Proceed, yes. Then your router will start to reboot. Okay. If you made your mistake in terms of configuration, that's what you do. Right, so let me make, right, my router is rebooted, so I'll start configuring again. Okay, so here we say int gig 0/0. Okay, so here we say, let me check if this is the port that I'm configuring. All right, so let me do this. So there's a problem in this cable. Gig 0/0 input. Right, so let me start configuring this one. Right, so I've picked this port. Let me say IP address 192.168.2.1 IP address 255.255.255.0. No shutdown like that. Right. Then we configure our DHCP IP DHCP pool 1 network 192.168.2.0 subnet mask 0. Then you say default router 192.168.2.1 DNS server 192.168.2.100. Right, we are done with that port. Right, so we need to go to the other port, to the serial port, to say int serial 0/0/0. IP address is 192.168.3.1, and this is /2/30, so it's 255.252, right? No shutdown like that. Still down because I need to configure the other port. Right, so for this router, the configurations are done. We need to go to this other router, start by the LAN. Okay, so enable the router. Come on, made a mistake here. Right, any questions so far? Whilst this is still translating my commands. Any questions? Okay, let me wait for this one to finish. Where are the other people? I think we've lost about 8 people here. What happened? Where's Kevin?
So I know for when we configuring the DCP, when we were configuring the DHCP, you did not exclude some addresses. So by default,
it is not a requirement.
Sorry?
It is not a requirement.
All right.
Yes. You can exclude or not. Right, so let me configure the LAN first. All right, so let me configure the DHCP pool 192.168.1.0 corresponding subnet mask is a /24, and the default router I can say 192.1.1, and then the DNS is 192.168.1/100. No problem. Right, so done with the LAN. Let's go to the one. So we say int serial 0/0/0, right? IP address is 192.168.3.2, right? So the other one, because this one was a 3.1, so this should be 3.2. And the subnet mask is 255.255.255.252. No shutdown like that. Right. So we now have a connection. So I need to give these machines their IP address by DHCP. So this one should be given 2.2. This one is given 2.3. This one is given what? 2.4. This one is given 1.2. This one is given 1.3. Right. So now, if I ping these devices, like this, you are going to see that the communication will fail. These devices cannot see each other. Okay. Why is it that these devices cannot see each other? Why? Why? Why is it that these devices cannot see each other? What is the major reason for that? Yes, Kevin?
Because we did not configure the route between the router 0 and router 1. So
Okay.
they cannot see the network.
Right, so I need to configure static routes. Instead, I can use dynamic routing, but in this case, I want static routing. Okay, so for you guys, you might be told that use static routing or dynamic routing. So here I'll say in configuration, we'll say IP route, right? IP route 192.168.1.0. The subnet mask for that network is 255.255.255.0. Exit gateway is this one. This is the exit gateway to this remote network. So the gateway address is 192.168.3.2. That is the exit gateway, right? Okay, yeah, I made a mistake here. This is 1.0. Okay, like that. 192.168.1.0. This is subnet mask for the network, and the exit gateway is this one. So this router is not aware of this network. So I have to configure a static router again, this router, so that it is aware of this network, which is 2.0. So I would say IP route, right, 192.168.2.0 is subnet mask, and the exit gateway is 192.168.3.1. Okay, so to this router, the exit gateway is this one, which is 3.1. Right, then we are done. So if I say to this router, show IP route like this, you can see that it is now showing us that it has learned about this router via this gateway and through static configuration. If you see an S, it means it is learned through static configuration, right? The same thing here. Again, let's now say show IP route, and you can see that it is learned about this network 1.0 via that gateway. Now let's ping these devices to make sure that they can communicate. So we can say ping, right? First packet. Now you can see that it's successful. The routing tables for these routers are now the same. So that is static routing. That is static routing. So for you guys, you now need to look at this network. Right, this network. So if you ask a question, how many networks are actually remote networks to router 1? How many networks do we need to configure so that the router 1 is aware of? How many remote networks are there for router 1? Router 1. Router 1 in my networks, in my remote networks mangani. Router 1 in my remote networks mangani. That is a very simple question. Nashe? In a one, which network?
Router 0.
What is the network? It is labeled.
One and 2 was
1.0.
1.
We have 1.0, 4.4, 2.0, 4.0, 3.0. So which remote network are you referring to?
1.0.
1.0, this one.
Yeah.
Okay, is that correct? To others? Router E, remote network here, one area E irabe. Right, what is a remote network? What is a remote network? What is a remote network? Okay, I think I'm talking to myself. So let me close this session. You go and do this. If you don't do that, I will give it some way. A test or what? You want to be spoon fed. So I'm closing this session. You go and do this on your own. Thank you very much for coming. Good day.